Let's start the word. How sound is produced? Very good. When anything vibrates, that produces sound. Sound is always produced when thing vibrates. Okay, so vibration always causes the sound. If there will be no vibration, there will be no sound. Yes, when anything vibrates, that thing produce sound. So if we will count the number of vibrations in 1 second, that is how we can measure the sound, by measuring the or counting the number of vibration in a second. And the number of vibrations in 1 second is called the frequency of that sound. Frequency is high, what does it mean? If thing has high frequency, what does it mean? Whenever we want to measure the sound, we measure the number of waves passing every second or in a second. So the frequency can be high, frequency can be low. High frequency means that in 1 second, more waves are passing through anything or any object. And low frequency means little number of waves are being produced. So high frequency are mostly of the loud sounds, and in that more number of waves passing in a second. And in the low frequency, the number of waves decreases. There is less number of waves that are passing every second. Getting? High frequency means more waves are passing in a second or produced in a second, and low frequency means less number of waves are passing in a second. Getting? So, and what is the unit to measure frequency? Unit to measure frequency is hertz. Just like we measure the length in the meter, we measure weight in the kilogram. So if we want to measure the frequency, we measure it in hertz. That is denoted by H and Z. Okay, let me show you a video about frequency, and then you will understand this concept better.
Hey, bubbly waves. Have you ever wondered how high these waves are? Or how long is one wave? What about the speed of these sea waves? But first, how do we define waves?
Excellent questions. Waves transfer energy from one place to another in a medium through a series of disturbances or vibrations that carry energy. Here are the basic features of waves: amplitude, wavelength, frequency, speed. These four quantities describe different properties of waves. Let's discover what each of these mean. First, let us look at amplitude. As waves travel, they create disturbance. The amplitude of a wave is the maximum distance of a wave's crest or a trough from its undisturbed or rest position. Think of a calm sea and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea level.
So, is amplitude the distance between a crest and a trough?
No, it is the distance of either the crest to the rest position or the trough to the rest position. Therefore, the vertical distance between a crest and a trough is in fact equal to 2 amplitudes.
Oh!
The amplitude of a wave is measured in meter, m. Next, let us discuss wavelengths. A wavelength is the distance between a point on one wave and the same point on the next wave. For example, these 2 points can either be 2 consecutive crests of troughs in transverse waves, or they can be the distance between 2 consecutive compressions or rarefactions in longitudinal waves. The wavelength is also the length of one complete wave. It is denoted by the Greek letter lambda and is usually measured in meters, m. The wavelength can vary greatly. X-rays are very short. Visible light is somewhat long, and radio waves are much longer. The frequency of a wave is the number of complete waves passing a fixed point in 1 second. Frequency is given the symbol f and is measured in units called hertz, Hz. Let's look at this wave, which is traveling from left to right. Can you count how many waves pass through point A in 1 second? Observe that in 1 second, exactly 3 waves pass through point A. Therefore, the frequency of this wave is 3 Hz. Lastly, let's discuss speed. The distance covered by a wave in a unit time is called its speed. Speed is measured in meter per second. Imagine seeing a flash of lightning and hearing the thunder of clouds. First, we will see the flash of lightning, and a few seconds later, we will hear thunder.
But why do we see lightning first?
This happens because both light and sound are waves that travel at different speeds. Light waves travel faster than sound waves. So, we see the light before we hear the sound. Sound waves are longitudinal waves, but the speed of the sound depends upon the type of the medium it passes through. Look at this table. Sound travels fastest in solids, then in liquids, and the slowest in air. Now that we have seen the 4 quantities, how are they related? Well, it turns out that the speed of waves is the product of the wavelength and the frequency. Therefore, waves with longer wavelengths or higher frequencies will travel faster. Note that the speed of a wave does not depend on its amplitude. Today, we've learned that amplitude, wavelength, frequency, and speed are different properties of waves. Amplitude is the maximum distance of a wave crest or trough from its rest position. Wavelength is a distance between 2 consecutive crests or troughs in a wave. Frequency is the number of waves that pass through a fixed point within 1 second. The speed of a wave is equal to the product of its wavelength and frequency.
So grade 4, are you all clear about the frequency? Sound is a form of energy. It is produced by vibrations and travels in waves. Sound is a form of energy. It is produced by vibrations and travels in waves. Are you all done? What is vibration? I'm telling the answer, everyone. I'm telling you about vibration. Start writing. A vibration is a recurring disturbance, recurring, recurring disturbance or movement that transfers energy through matter. Okay, now let's move toward the frequency. Frequency is the number of vibrations per second. Frequency is the number of vibrations per second. Okay, Allah Hafiz.